The purpose of this study was to originally was to gauge the detrimental disturbance that occurred post-harvest. But the more important purpose of this study was to gain insights as to what's going on in the woods in terms of ecologic trends, fire hazard, overall landscape water holding capacity, and damage to soil that we couldn't, that didn't fall under the Forest Service's guidelines. Let me see if this works. There we go. This is the methods that we used were the Forest Service's own, and we tried to stick to them pretty good. And so we used their assessment techniques. Now I got to tell you, some of their techniques could not detect some of the things we saw, and they were some of the more important overarching impacts. And we'll get to that. This is the data form that we used, and you can see all kinds of interesting things in there. We measured everything from ground cover to detrimental disturbance to tons per acre of woody debris, and put it all together. We also tried to qualify ecologic trends and fire hazard and things like that. And those things, and biophysical resiliency to disturbance, which is something that's a little bit hard to determine. You have to use all your insights there. This is the summary of all the data, and it's just a bunch of numbers right here, but the big take-home messages here are these soils are very fine textured, meaning they're vulnerable to compaction, and they have a low rock content, which means they're even more vulnerable to compaction. Believe it or not, most of these units did not have a lot of detrimental disturbance. The Forest Service and the loggers did a pretty good job of keeping the disturbance down. There's an exception in 3 units where they did a heck of a lot of damage. And then one of the big findings was a lack of coarse woody debris. Your normal load of coarse woody debris should be around 10 tons per acre in this forest type, and we were getting 2 to 3. It was not much. So those are the highlights of our actual data collection. But along the way, we learned a lot more. I thought it might be useful to give you guys a little bit of primer on soils and to give you an overarching view of what's going on. Soil, as you know, is made up of sand, silt, and clay. Sand being that big circle in there, and then silt being that other one, and then clay being the tiny, tiny one. And the important thing to know is sand is broken down rock, silt is broken down rock, and clay is not. Clay is dissolved silt that comes out of solution as a crystal, and it's magic stuff, and it's very different. So don't think that clay is just finely ground down rock. It's completely different. It just comes from rock. Soil texture, as you see on the little screen there, is the relative amounts of sand, silt, and clay. Soil structure is how these aggregates of sand, silt, and clay are glued together. And that's going to become real important in this talk. So soil structure and soil aggregation is something that we really need to start thinking about. Pore space is just the empty space between the little clods of dirt. And gas exchange is just what it sounds like. It's air exchange in the soil, and extremely important to plant growth. And then water holding capacity is a little bit of all of that. In your ideal soil, you'll have 50% solid and 50% pore space. So half of that soil should be empty. And then of that pore space, the micropores should be filled up with about 25% water, and then the other half, the other 25%, is air and for gas exchange. So there's a lot of gas exchange going on in the soil. Now, here's an awesome photo of a soil aggregate, and the basis of this whole talk, really. Soil aggregates, like we were talking about, are the aggregation of sand, silt, and clay particles all together and glued together with biological goo. And that goo comes from all kinds of things, but mostly fungi. And so the more biologic activity you have in the soil, the better off your aggregates are. Now, a lot of these aggregates, we hope, are water stable. So water stable aggregates is really the key to the watershed soil health. Here's a good photo of some water stable aggregates on the right. And you can see there's more organics in there. And on the left, that's kind of a dead soil. And it's important to remember that aggregates, especially water stable aggregates, are created and maintained by soil biologic activity. So bioactivity under our feet is extremely important. If you don't have these water stable aggregates being created and maintained, when the water hits it, it turns to pudding and you get something, looks like the cat did it right there on the left. This is how we measured rock content out there. Just a sieve, 2 millimeter sieve. I was very surprised at the fine textured soils in the Black Hills. There's rock just a few inches down, but from 0 to 6 inches, there wasn't much rock, except for on a few units. This is how we measured compaction. All of you that were on the study, you know that we poked thousands and thousands of holes with these things. Here's another way to tell compaction. This is platey structure. If you dig a hole and break up the soil and you get these little plates, you know that's not awesome ground. It's been compacted. Here's a great example of the soil organic horizon. It's this one is root tight and fungi tight, as most of them are, meaning it's going to be resistant to disturbance. If you were to push a fire over the top of this, things would sprout right away. It also holds a heck of a seed bank. So this is an indicator of a good, healthy soil. So here's the kind of the summary of what we found in every unit. We found moderate compaction everywhere, and I mean everywhere. It was kind of surprising. After being cut 2 or 3 times and having cows on it and all the rest of the things going on up there, this entire landscape has been compacted. It's not the kind of compaction that the Forest Service deems detrimental. It's less than that. Still, it's detrimental. It can really screw things up. And the way we compared it, we found spaces that we knew couldn't be compacted, like between trees or a place a cow couldn't get into or a place a machine couldn't get into. We also found charcoal in every unit, in almost every shovelful, indicating a long history of low severity fire through the years. And as you can see in this photo, we found an increase in fire hazard on every unit. And that's because the shade trees have been taken out, the understory grasses grew well and created something that would start these little trees on fire. So every unit had an increase in fire hazard and a decrease in ecologic integrity on every unit, mostly because of weeds and that increase in fire hazard. We found a decrease in annual litter contributions. That's just because there was less trees to contribute every year, and an increase in organic matter decomposition. And that was mostly due to a rise in surface temperatures because of the big trees being taken out. And then on every unit, of course, we found slash piles. And I was pretty surprised at the amount of ground that is under these slash piles. It's significant. Most of these forests have been logged at least twice. There's probably some out there that have been logged 3 times. Here's a typical stand here, this overstory removal. When I first heard that term, I thought they were joking. Overstory removal, that's something they used to do in the old days. You know, they call it high grading then. Now in this stand that you're seeing, this is pre-timber stand improvement, pre-TSI. And hopefully the idea is the Forest Service is going to come back in and thin these small trees out. And they've done that on a few units, but most of them look kind of like this. Here's just another typic stand we found out there. Look at the tractor alleyways and those tight clumps of trees. All the overstory trees removed. Another just typical cut. It's very unusual for me to walk into a forest and find big stumps and teeny trees everywhere. So that's not the way forestry is done anymore. It was just a few years ago, but things have changed, luckily. Here is one where the timber stand improvement work has been completed. And you can see they went through there and thinned it pretty nicely and just laid it on the ground. And I don't mind that at all. It does increase the fire hazard for a short amount of time, but we have to also consider ips, which is a type of bark beetle, can get into this stuff. But all in all, this is a pretty good job. Here's a typical slash plow. These are just everywhere and bigger than I can imagine. Now, talking about ips habitat, this is where they're at. The ips beetles, that bark beetle, can have 3 and 4 broods in a pile like this per summer. And this is what it looks like when the slash piles are burned. It's pretty ugly, and this land is kind of out of production for a while. It's not coming back. One thing we saw was a big increase in exotic invasives. The weeds were pretty intense and they were everywhere. And that was a little hard to stomach. And it's one of the impacts that the Forest Service doesn't consider significant, but it certainly is. It'd be very difficult for pines to recolonize this site with that kind of weed base. This is another just typical cut. This is an ORV trail. So this is what your tourists are seeing now. Instead of a forest with larger trees in it, it's the aesthetics have really been knocked out of it. And we have to admit these days that recreation is is the driver, and this is no way to promote quality recreation. Yeah, just another sample cut here, and notice those tractor trails that go through there. That when the skidders take logs out and they cause those trails, the trees don't come back up in them. And that's mostly because of the very vegetation tight ground cover. They have a hard time regenning on this stuff. So here's another, this is on a pretty nasty site. This is one of the units that had more disturbance than most. And this is where I'm going to get into talking about overarching impacts of logging on soils. And this isn't just in the Black Hills, it's everywhere. And it's ubiquitous throughout the entire West. So with compaction, even that moderate compaction that we found everywhere, we're finding decreased water infiltration, which of course leads to increased overland flow, which leads to increased floodwater volume and energy. And the energy is a big deal, because with that comes increased erosion and then increased sediment delivery. And then you get incised stream channels in some places, and you get sediment choked channels in other places. And then the big impact of that is late season spring flow reduction. So later in the season, places that used to have water in them no longer do. And then we have compromised soil aeration and associated poor plant growth. Anytime you knock the air out of the soil, you're going to reduce the plant vigor. And the overarching impact of all that is desertification. And we've been seeing it all over the West. In my short time, 30 years of looking around, I've seen at least 15 or 20 streams completely disappear. They're gone. The foundational causes of all this are the loss of soil organic matter. And remember, that's associated with water stable aggregates, soil compaction, and roads. Road systems are a big deal. They're like gutters. They focus all the water into smaller channels with high energy and push the water right off the landscape. So roads can be very detrimental in that way. Now, soil organic matter can be lost in a whole bunch of ways, like we were talking about, increased decomp rates and changes in microclimate, physical displacement, which in this photo you can see it, it was scraped right off and who knows where it went to, biomass removal through logging, and then annual litter contributions associated with tree removal. And then of course, fire. But when fire removes biomass, it's a little bit different. You, on a perfect day, you retain the duff, but lose some of the litter. Now you can relieve compaction in 3 ways. I don't want to give you guys all doom and gloom here, but 3 ways to remove it. Mechanical, which is just like a dozer or a tractor that scratches the ground and decompacts that way. And I got to tell you, the best science says that is not a great method. It typically just falls back on itself and recompacts. Natural freeze, thaw, and wet dry cycles do decompact. And that on a really compacted fine soil like in the Black Hills, that can take up to 60 to 80 years to decompact naturally. Or the third one there, increase soil biologic activity. That one has been working really well. And the way that we increase soil bioactivity is by adding organic debris to the top. And that's easy. That's just logging slash. So for example, in this photo, if we were to throw a bunch of slash down on there, the soil fungi would bust up through the compacted soil, grab their carbon and bring it back down to depth, decompacting the whole way and creating water stable aggregates as well. In some of our research a few years ago, we purposely smashed a piece of ground and just was as rough as we could be on it, killed all the water stable aggregates, measured them, and found they weren't even there, and then slashed it and waited for the water stable aggregates to return. And it took about 2 years and they were back. And now our experiments have been going on long enough to where we've figured out that with a good slash loading on there, you can decompact an area in about 25 years. And that's relative to the 80 years through other means. Here's something you should keep an eye out for, an incised stream channel. I didn't get to look at many streams in the Black Hills, but these are all over the West and they're a serious deal. When a stream gets incised, it cuts down through the earth in a rather rapid way. This one in front of you, that cut down 4 to 5 feet in just 2 seasons. And whenever you see this, the water table drops with it. And that means the active layer is devoid of water. And all those trees you see in the background, they're dying of drought right now. So pulling that water table down to depth is really wreaking havoc all over the place. As you drive around the West, you might see fields of willow that look dead. And that's what happened, is the water table dropped and it's out of the range of those roots. Here's what happened to all that sediment. It filled up the stream channel completely, and you don't get any flow in here except for a few weeks in the spring. But mostly it's just all underground now with no surface water at all. And this is a very common situation. Another strange compaction situation is a raindrop compaction after a fire. So a burned soil is very vulnerable to getting the infiltration rate compromised, because raindrops can actually compact it just enough and clog up those aggregates to where it doesn't allow infiltration and you get overland flow. And that's why we have floods after fires. It's because the pore space gets clogged up. And of course, as you know, in the Black Hills, this is a shot in Montana, but cows. Cows are a big deal. They walk all over the land every year and they are great at compacting. You can't see the compaction, but it's there. If you've ever had a cow step on your toe, you know that they can really put on some pressure. Cows, after a cut, are all these layers of disturbance, one after the other, all this picking of the scab is really what's causing the damage, this persistent disturbance every single year. And none of this is new. None of this is new to science. This is a quote from one of Plato's writings from over 2,000 years ago. And he saw the very same thing we're seeing now and that you folks have seen. Yeah, he said, what remains of our rich land is like the skeleton of a sick man, with the fat and soft earth having wasted away and only the bare framework remaining. Once these mountains were arable and the valleys full with rich soil, now the valleys are marshes and provide only food for bees. Once the land was enriched by flowing water that was held into the mountains, and now it is lost by flowing from the bare soil to the sea. When the soil was deep, it absorbed and held the water, and the water then soaked into the hills and fed springs and running streams. And now the abandoned shrines at these places that were once springs attest that our description of the land is true. So nothing new here. This has been going on for thousands of years. We've just been a little bit, it's new land to this kind of disturbance. But with diesel power and increased grazing and overlogging, all these things exacerbate to really cause some problems. And we haven't even mentioned global warming. So it's that's going to exacerbate things probably even more. This is a photo I took in Lebanon. I spent some whiles over there doing some watershed work. Now notice, Beirut gets more rainfall than Nemo. And this photo was taken outside of Beirut in mountains where it gets probably 30 inches of rain. Their country, even with that rain, acts like a desert. The water runs right off, big floods, and it's a heck of a mess. And right now, the only thing they can grow there are olives and goats. So you start seeing people moving into your territory with olive trees and goats, you better think again about what's coming, I guess. Are there any questions for all of this?
Yeah, Mark, I've got a question. Can you hear me?
Yes.
Just a question about the slash piles that we see all around the forest and all these timber cuts. And so is your message that they shouldn't be stacked like that and burnt, but rather dispersed, left where they are on the ground, and that would be best for the soil and the forest in the long term?
The first thing is not to create so much slash, and then do a combination of lop and scatter. And it would be great to have the bigger sticks scattered around the woods. And sadly, in the end, some of it should be piled and burned, just out of practicality. You can't put too much slash in the woods or you might cause too much of a hazard. Big stems don't cause a hazard. It's those red needles that really do it.
How do you create less slash?
Take fewer trees. As you saw, the Black Hills can produce ponderosa unbelievably well. And that's not normal in a ponderosa forest to have that kind of dog hair stand. But thinning, persistent thinning through the years where you don't have such a glut of slash in the end is probably the best way to go. What do you see is happening ecologically in the Black Hills in terms of desertification? Well, just all the things that that we noted there. It's not desertifying now, and it won't in our lifetime. It's just this slow change in the biophysics of the soil that are going to cause it into the long run. And so what we are seeing is that compaction everywhere and increased overland flow. And I've heard folks say that they think the floods are worse, and I can't attest to that firsthand, but I've heard it secondhand.
West or in the Black Hills?
In the Black Hills and in the West for sure, but I've seen it all over Montana, so I know for sure firsthand there. But I don't know about the Black Hills.
Mark, are you familiar with the cumulative mean annual increment? It's silviculture, forestry terminology for, like cutting the tree when it's created the most volume it will in the shortest amount of time, so you can start new trees to grow.
Oh yeah,
and
yeah, I'm very familiar with that.
So is there it seems to me like if you're really looking after forest health, there's a little bit of a disconnect between the CMAI you know, the efficiency, what we call efficiency, and really the long-term stability and health of the forest. Does that strike you as accurate?
Yes. And what people are learning and what they put forth in their silviculture equations are often and most often off. And here's why. So you get that mean annual increment you were talking about, and that's just basically the size of the rings, and they usually measure it either per inch or per 10 years. If you have a tree that's let's say 8 inches around and it's producing a 1/4 inch ring, boy, the foresters love that. And then they'll notice that the ring size is getting smaller as the tree gets bigger. But that doesn't matter. They're still putting more volume on because it has to wrap around the entire tree, and you've got another log on top of that one. So when I was studying silviculture, I was sitting there in class listening to the instructor, and I thought, geez, this doesn't sound right. So by hand, I worked out all these calculations, and sure enough, you can have a big tree that's producing microscopic rings, and it's still putting more volume on per year than a small tree, easily, and higher quality volume as well. So I'm a big proponent of growing big trees bigger, both for future timber and for the ecologic integrity of the forest. Big trees are the answer to almost all our problems, except for soil organic matter.
Are the tighter rings stronger than the
Oh yeah,
wider rings? Like a
you
tree
bet.
that grows fast and has wide rings, is that a weaker tree in a
It is.
snowstorm or windstorm?
It is weaker, yes. And as a matter of fact, in places where there's an understory, you don't have this problem in the Black Hills, but in some places in the West, they have understory of Douglas fir that is suppressed. And so the rings are really tight. And that stuff is awesome. It acts just like old growth, and it's the strongest wood around. And it's because it's been grown in a shaded environment and the rings are tight.
Mark, can you see any parallels between like farming and agriculture and like the Forest Service industry?
Yeah, they like to call their harvest, you know, they call them harvest, the logging and crops and such, and the short rotation ages. So yeah, they tend to think that way, but I'll have to say they're thinking less and less that way these days and into the future, and they're thinking more about ecologic integrity. But the agriculture world does seem to spill over in forestry more often than we'd like to see.
It does seem like the hardest part of being a Forest Service employee is just finding the balance between all the fingers in the pot. And so then my next question would be about cows, like grazing pressures within forests. What are your thoughts on that?
Oh boy, my thoughts, or my opinions really, are I don't like to see cows in the forest much at all. It just doesn't seem a good place for them. You know, they can, I guess if you had just a few in there, it wouldn't be a big deal, but it seems like they do so much damage. And you saw the compaction out there. Everywhere we went, a cow had been. And so, and you can't see that damage. It's just, you have to use, you know, that penetrometer to really discover
You
it.
can't see the damage except for around the riparian zones, right?
Oh,
Thank you.
riparian areas and cows, those two things, yeah, they don't go together. If it wasn't for cows, I wouldn't have anything to do out here in Montana. So yeah, they do, the cows do most of the damage that I'm trying to fix these days.
Sounds good. Thank you.
Somebody had a question.
I just wanted to say one thing. You know, you're going to write a report on this, your findings, and give to the Norbeck Society so that we can start making comments on projects and so on in an ecologically healthy direction. But it still seems like it's going to be a major turning of the boat to do something that will change this trend.
Yeah, that's why we tend to get discouraged in all this stuff. But there is the trend right now is pretty good. I mean, they've stopped this overstory removal, which is one good thing. They're doing pretty good forestry in other parts of the country, and so the trends there are good. It's just the bureaucracy is so tied up now and then. So
So I clarify, Mark, so the Black Hills Resilient Landscapes Project, we were told earlier this year that the overstory removal part was not very popular at all with anybody, and they were stopping that. But I should mention they've got the 3 chipmunk projects, Alvin, Theodore, and who's the third one? And then also a new project, the Mosky Burn Project. And those were all old burns where I guess then they planted trees that where the DNA was not congruent with that site. So then they've, you know, over the years since, a bunch of scrubby little small trees have grown up. And so they're clear cutting those areas and then replanting them. I couldn't tell you what the acreage is, but it's substantial. Actually, we
Yeah.
were right next to, on the first day out, when we were in Wyoming, we were right next to a forest that was one of those that are now proposed to be clear cut. Different from OR, you know, overstory removal. So there won't be any little trees underneath. They'll just be completely
yeah,
detreed.
yeah, that's a big problem all throughout the West, this off-site ponderosa pine, and I'm afraid it's real. Ponderosa pine is really sensitive to its place in the world, meaning that if you're going to plant something in a ponderosa in a specific valley, you should get your seeds from there. Other trees are way more flexible, but ponderosa is very, very persnickety. And those trees grew up to be about 65 years old and they die. And they do it all at once. It looks pretty bad.
So what about climate change? If we're expected to, in, you know, 80 years to have the climate of, you know, a more southerly latitude, would it be some advantage to have different, I mean, I don't know where the DNA came from in the trees that exist there now and at these sites, but
That's a
are
good point.
ponderosa, yeah, are Black Hills ponderosa going to be able to survive here?
Yes, and the reason is, luckily, there's tons of mutations in every batch of seeds. As an example, it's been during the 900s to the 1400s, there was a weird warming spell throughout the entire planet. The whole planet was about 6 degrees warmer than it is right now. And they found in Colorado, on a really neat study they did, ponderosa pine changed its genetics and went up and over the divide during that warm time. So it had enough plasticity in its own genome to figure it out and do what needed to be done. And I'm always surprised at how quickly those mutations will express themselves when it comes a time of need.
It's asked how much of a hole with good soil would a small tree need to penetrate into the compacted soil?
The key is to bust through that compacted soil when you're planting the tree, I guess. And in the Black Hills, that compaction goes pretty deep because it's fine textured, and they did a lot of their logging when it was moist. The season of logging makes all the difference. If there's any moisture in the soil, by golly, it'll really compact it. But I'd say the first 14 inches or 16 inches are going to be the worst, and then after that, you'll be home free. Now, luckily, they can penetrate. They just don't like it, especially ponderosa. If you get them as a 10T, 10 cubic inch container, and that taproot is still intact on the bottom, they'll punch through it pretty well. And then you can add soil bioactivity to your hole if you need to, just by having some organic matter down there.
I have a question about mycorrhizae. And
Uh-oh.
so what do you feel about what's happening to the mycorrhizae, and is it getting depleted? Will we lose that through all this compaction process?
It doesn't like compaction. Mycorrhizae is the best fungi to build water stable aggregates. And you do lose some of the mycorrhizal connections when these big trees are taken out, because the mycorrhiza species are different between big trees and small trees. So those big trees, their connections, they're not going to like that at all. We won't lose it. To lose that is really, really tough. In the middle of a big pile, a slash pile that's been burned, you've lost it there. But it comes back in a few years. You can barely keep it out of there.
What do you think about chipping? I know that they're doing more of that around the Black Hills now.
They're doing a lot of chipping and masticating. I don't mind it too much. It tends to increase soil bioactivity pretty rapidly and vigorously. So when you put down a layer of chips, no more than 3 inches, that's actually all right. That does some good. If you get deeper than 3 inches, you tend to keep the frost in the ground a little longer than is natural. And so it's all about soil temperature after that. But I've had really good luck with chipping. And masticating, it leaves chip-like things behind. The problem with mastication is they usually drive a big heavy vehicle all around the woods in a wet time of year. And we've seen more detrimental soil disturbance from mastication than anything else. If the operators were on the ball and they did it during a dry time of year, that would be different. But as it stands now, the actual soil disturbance from mastication is fairly significant.
I have found a spot in the Black Hills, just on the edge of Rapid City, just outside of town, where they had a logging deck that they had done a lot of chipping and shredding, a fairly large area, almost an entire acre. And after the logging deck was finished and they left, we had an amazing bloom of morel mushrooms. And I went in, I was pulling morel mushrooms that are 8 inches high and 4 inches across the base. It was phenomenal. The following year, 0 morels. And there was an amazing bloom of all kinds of invasive weeds. Now, 15 years on, the non-native invasive weeds have been choked out by more natural growth. And so I think I agree with you with the chipping and shredding being far better for the forest than the piled up, burned out, and dead soil that comes from underneath that.
Yeah, it's a lot of effort to chip, sadly.
Yeah, it is. And when I worked for the National Park Service up at Mount Rushmore, they had just purchased a monster machine that would take 10 to 12 inch diameter trees and just throw them out the other side as chips. And they started using more of that. And in my experience, the soil came back a lot faster, and the native species came back a lot faster that way.
Yep. I believe it.
You know, I know at one point they had estimated that there were 6,000 of those piles on the forest waiting to be burned.
Oh, geez.
I don't know what the current status is, but you know, since I heard that, they've burned some and added some. And I would guess that those, the area that's impacted by one pile, well, it varies. I think the photos you showed, Mark, showed some of the smaller piles. There's some that are, the size of 3 barns lined up. But they must be an average of 3 acres anyway, or maybe 5 acres of direct, implication. So, I mean, that's maybe 30,000 acres of the forest is wrapped up in these slash piles.
Yeah, it's a big deal. And I see Ben put up a message there that someone at the university's trying to make chipping profitable. That would be nice. And a lot of places the chips are valuable. They use them as hog fuel for the sawmills and actual fuel source. And that's an okay thing, as long as they don't get hooked on it as an energy supply and go overboard like we always seem to do.
Years ago, I heard that furniture makers like it because of its dense rings.
Yeah, years ago, the heartwood to sapwood ratio on a ponderosa pine is way different than you see now. And it's the heartwood of a ponderosa that's awesome. And then, back in the day when the trees were big, the whole interior, 20 inches across would be heartwood, and you'd have a ring of sapwood on the outside. With these trees that are 15 to 20 inches, you have a small 4 to 5 inch chunk of heartwood, and the rest is sapwood. And the sapwood, in my opinion, in our sawmill, that is not good stuff. It's hard to deal with. But whenever we cut, if we ever have to take a large ponderosa down, that heartwood is amazing stuff. That's the real wood there.
How old before a tree has like even
Um,
an inch of heartwood?
Well, you can see that reddish color inside of a ponderosa. Gosh, it's got to be 30 inches before you get any useful heartwood out of it. The heartwood in a tree is the garbage disposal system for the entire tree. It's where all the used up metabolites are stored, and so all the pore space inside of the tree is just full of junk that basically petrifies it. It mineralizes, not petrifies, but mineralizes, and that's why that heartwood is such strong and stable stuff.
Well, Mark, I sure appreciate you being with us tonight.
Oh, my pleasure.
We're really looking forward to your report and employing some of your advice as we write our comments on projects with the Forest Service. So I feel like our time with you has been invaluable, not just tonight, but the week that you were here in August and our visits in between. So
That's good to hear. Thank you. Yeah. All right.
Thank you for the education. Thank you very much.
Thanks, Mark.
wonderful.
You bet. All right. Well, I'll sign off then. Good night, all.
We'll see you around.
Night, Mark. Thanks again.
See you, Ben. You did it. Yeah, it looks like.
So he's sieved out all this, he separated the big stuff from the little
Yeah.
stuff here.
And I'm trying to estimate the rock content as well at the same time. So we've got the organics out, leaving the rocks in here. Probably only 5% rock, and the rest of this is mineral soil here. And now we're going to determine how much sand, silt, and clay is in the mineral soil. And that'll tell us a bunch of stuff, including water holding capacity, compaction, how sensitive it is to compaction, and how it might heal from compaction as well. And we're finding little bits of charcoal in here even at depth, so evidence of fire going back a long time. And charcoal has a residence time of 500 plus years. Want to give this a try?
Sure.
Yeah, take a handful of this. Yeah. And this is other parts of the forest we've been to, especially on the limestone, was just full of highly aggregated soil. This is not. This is very unaggregated, which surprised me. So we'll just get this water here in a second. This takes quite a bit of doing. Just hand this to you. The more rock content the soil has, the more resistant it is to compaction. And the magic numbers is about 35%. Once you get 35% and over of rock content, the soil compacts much less. So you can extend your work seasons a little bit more and feel a little bit better about how your machines are impacting the soil.
So then the soil that you grabbed just now would be at high risk of compaction due to overgrazing or something like that?
Who knows why, but yeah.
Okay.
Yeah, that
we're finding compaction almost everywhere. This soil does not make good platy structure, but on the limestone we were finding lots of plates caused by compaction, even where machines weren't, leading us to believe it was probably cows. And it was at depth. It was strong compaction at depth.
So like historic compaction then, potentially?
Yeah, well, cows of last year and back 100 years.
That's what I'm saying, okay, so yeah.
Yeah.
So it's more than 1 year. with
Yeah,
it.
yeah, and they're out there wet, dry, it doesn't matter. And I don't know if you've ever been stepped on by a cow, but it
Can't say
hurts.
that. I bet it does.
They're heavy, and they really drive compaction to depth. So the second step here, once you get it about the consistency of Play-Doh, let's see what you got there. It's pretty good. Then we form a ribbon, and it's the length of the ribbon that tells us the clay content. And I just make a little crook of my fingers there and make it even width and depth throughout, expose it to gravity, and then it breaks, and you measure this. And it's the length of this ribbon that classifies your soil texture, meaning sandstone clay. So that was between 1 and 2 inches. Yep, same.
Facile with making the ribbon.
It took a
Definitely
little
skill.
practice.
Play-Doh in mine. I want some blue.
Yeah, I know. Let's get some color in there.
Yeah, mine's been pretty consistent about that.
I mean, I can baby it along, but you're not supposed to do that.
No, you don't want to. You don't want to baby it, but you want to expose it to gravity and see where it breaks. And the key is, I think, that little niche I make so the soil profile goes through there, that very same shape throughout the ribbon.
I had to do it about 10 times before I could get it to.
So this soil falls into the clay loam category, and now we want to see what kind of clay loam it is. So let's take about a pea-sized particle, clod, get it real wet. And, feel the sand in there, and if you pour this water out, you can actually see it. And you're saying to yourself when you're doing this, is it real smooth? Is it really gritty? Or does neither characteristic predominate? And I'll have to say, neither characteristic predominates on this. There's sand in there for sure, but it's not a ton of it. Yeah, it's probably less than 10%. So this is just a plain old clay loam.
And so, like, the long description of that really is about the size of the particle, really, and the parent material.
That's right. But the parent material has an effect on things. For example, the parent material can have chemical properties that hold on to water stronger. So limestone, when it degrades or decomposes into soil, it brings along all of its calcium and other things, and that stuff really holds on to water. So the same amount of water goes a lot less far in limestone